guys, it's me Jerome and welcome to another vlog tutorial. So today we will gonna tackle about a lesson in statistics and probability, and that is the normal distribution. But before that, let's go with our objectives. So for our objectives, we have number 1 is to know how normal distribution works. Number 2, know the meaning and variables of the empirical rule. And lastly, for number 3, know how to solve real-life problems using normal distribution. So normal distribution. Normal distribution is the proper term for a probability bell curve. It is a continuous probability distribution that is symmetrical on both sides of the mean. So the right side of the center is just a mirror image of the left side. And the area under the normal distribution curve represents probability, and the total area under the curve sums to 1. It is also called Gaussian distribution. It is the most common distribution function for independent randomly generated variables. So in statistics, this graphical image that you can see on the left side of the presentation is called the normal curve. And the normal curve does not intersect or interact with the horizontal axis, as you can see on the graphical image. Also, the mean, median, and mode of the normal distribution are all equal. So let's move on to empirical rule. And the empirical rule, also referred to as the 3 sigma rule or 68, 95, 99.7 rule, is a statistical rule which states that for a normal distribution, almost all observed data will fall within 3 standard deviations of the mean or average. In particular, the empirical rule predicts that 68% of observation falls within the first standard deviation, 95% within the first 2 standard deviations, and 99.7% within the first 3 standard deviations. And the remaining 0.30% is distributed equally on the both sides of the curve to get a total of 100%. So meaning yung 0.30% is hatiin natin to get a 0.15% on both sides. And as you can see, merong equivalent na percentage on the standard deviation, on each standard deviations. So for the middle part, we have here 34% on each sides. Then for the following standard deviation, we have 13.5% each sides. And the next standard deviation is 2.35%. And as I said earlier, the 0.15% is nasa dulong bahagi ng bell curve. So let's move on to our real-life problem. And our real-life problem is the distribution of the shoe sizes among 3,000 Filipino women is normally distributed with a mean of 8 US size and a standard deviation of 2 US size. And as you can see on the left side of the presentation, we have here our graph. And this graph will be used on the following solutions. So here we have our following questions to answer using the empirical rule. So for number 1, how many Filipino women have a shoe size between 4 US to 10 US? 2, what is the probability that a Filipino women have a shoe size of at least 6 US? 3, in 3,000 Filipino women, how many got a shoe size of more than 12 US? 4. If a random Filipino women are selected normally, what is the percentage have a shoe size of less than 8 US? And lastly, for number 5, what is the chance that among 3,000 Filipino women have a shoe size at most 12 US? So let's answer question number 1. That is, how many Filipino women have a shoe size between 4 US to 10 US? Then we will shade the part between 4 US size to 10 US size. Then we will refer to the empirical rule that we discussed later, and we will get the equivalent percentage on each standard deviation. So here we have 10 US size to 8 US size, we have 34%. 8 US size to 6 US size, equivalent to 34%. 6 to 4 US size is equivalent to 13.5%. Then let's add, we have 81.5%. And since tao ang kanyang tinatanong, hahanapin natin yung 81.5% ng given population, which is 3,000 Filipino women. So, 81.5% of 3,000 is equal to 2,445 Filipino women. And that is our final answer for question number 1. Let's move on to the question number 2. So we have, what is the probability that a Filipino women have a shoe size of at least 6 US? So meaning, dapat ang shade nating part is dapat hindi bababa sa 6 US. So let's get the equivalent percentage. So from 6 US size to 8 US size, we have 34%. 8 US size to 10 US size is 34%. 10 to 12 US size is 13.5%. 12 to 14 US size is 2.35%. And the 0.15% will be added, a total of 84%. And that is our final answer. So let's move on to the question number 3. In 3,000 Filipino women, how many got a shoe size more than 12 US? So meaning, yung shade nating part dito is dapat mas mataas sa 12 US. So from 12 US size to 14 US size, we have 2.35%. And the remaining 0.15% will be added, a total of 2.50%. And since tao naman ang kanyang hinahanap, is hanapin natin yung 2.50% ng given population, which is 3,000 Filipino women. And the 2.50% of 3,000 is equal to 75 Filipino women. And that is our final answer. Let's move on to question number 4. We have, if a random Filipino women are selected normally, what is the percentage have a shoe size of less than 8 US? So meaning, yung shade nating part is dapat mas mababa sa 8 US. So from 8 US size to 6 US size, we have 34%. 6 US size to 4 US size, we have 13.5%. 4 US size to 2 US size, we have 2.35%, and the remaining 0.15% will be added. A total of 50% is our final answer. So let's move on to our last question, question number 5. What is the chance that among 3,000 Filipino women have a shoe size at most 12 US? So meaning, yung shade nating part is dapat hindi lalagpas sa 12 US size. So from 12 US size to 10 US size, we have 13.5%. 10 10 to 8 USIs, we have 34%. 8 USIs to 6 USIs, we have 34% again. And 6 to 4 USIs, we have 13.5%. And 4 to 2 USIs, we have 2.35%. And the remaining 0.15% will be added per usual. So, our final answer here will be 97.5%. And that is all the questions for our real life problem. Let's go with our quotes. So, don't forget that Albert Einstein says that as far as the law of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality. And that is our presentation for today. I hope you can learn from me. And lastly, thank you for watching.